Hello everyone. So we are going to do our class 38 today, and I would like to start with a quick review of class 37. And earlier I also shared previous stuff that we covered from chapter 10. So I'm gonna add those also as the review. But I want to focus on torque and cross product for this review. So the torque is defined as R cross F, right? And we use a cross product. So torque is the Greek letter tau. So it looks like a curled T. And it is a vector. That's why I put a vector sign on top. And it is the vector product of R and F. And the order matters. So it has to be R cross F, not F cross R. Okay, so this is our definition of torque, and let's just kind of analyze it and kind of review what this means in terms of couple things and some couple key things as well. So I'm going to start with the magnitude. What is the magnitude of torque? So this is again a vector equation, right? And magnitude is, so torque, again, I'm dropping the vectors signs on notation on top. Torque is RF sine theta. This is true for any cross product. Okay, if you have A equals to B cross C, then A magnitude is BC sine theta, for example. Any vectors. And this is the torque definition, so I'm going to focus on this cross product here. Okay, so this is our equation. So this is the magnitude. All you need is the magnitude of R, magnitude of F, and the sine theta. And I'm going to talk about what those R, F, and thetas are. Direction, since again it is a vector product, torque is a vector. Direction will come from right-hand rule. Okay, RHR stands for right-hand rule. And specifically, this means the resultant vector, in this case it's torque, so the result is your thumb when you apply right-hand rule. And the first vector in the cross product, that would mean R in this case, is the forefingers. And the second vector kind of is your palm, okay? Oh, that's kind of where you are curling forefingers towards. Okay, so again, if we do this for torque, it's not thumb, it's thumb. Okay, if we do this for torque, so torque is going to be the thumb. If you already know what R and F vectors look like, you can point your forefingers along the R vector and then curl them towards the F vector. Then the thumb, stretched out thumb from the forefingers, like 90 degrees between them, is going to point along the torque direction. You can also define it as clockwise, counterclockwise, and it's this kind of same thing as finding the direction of thumb. Okay, there's a relation between them. So that is basically what it is. The torque comes from a cross product, and cross products are vector products. You need to remember that torque has a direction as well as the magnitude, and the magnitude comes from RF sine theta. Direction comes from the right-hand rule, and so we are practicing right-hand rule in the torque concept in this class. Next semester you will have a lot more right-hand rule coming up, so it's really important that we understand most of it right now so that we don't have trouble next semester. Okay, so the couple key things about in here, the result is always perpendicular to the vectors in the cross product. So what does that mean in terms of torque equation? It means that torque is always perpendicular to R and torque is always perpendicular to F, always. That's because of the right hand rule. Okay, again, we are using 4 fingers and palm. If you look at your thumb, it is always perpendicular to your 4 fingers and the palm direction. And when I say palm direction, it's like, think about the direction of which way it's facing. So kind of remember the normal vector. So kind of point it coming out of your palm, okay, perpendicular to your palm. And the thumb is always perpendicular to those, okay? So that's an important thing. I'm trying to put a, I'm going to put a check mark here. So that's one of the things that is important. Another thing is, let's understand what those mean one more time. R is called as moment arm. And it is in meters, in SI units. It's a vector. It is measured from the pivot point to the force point. So it is so important that you see where the pivot point is. Okay, that's like kind of your origin that we use in the kinematics equations, like the constant acceleration equations or motion problems. You need to know where the pivot is, where is the rotation axis, okay? And then you are gonna measure your moment arm from there. And you're gonna, since it has a direction, you have to start from the pivot point, go all the way to the force point where the force was applied on the object, and draw a vector pointing towards the force point, okay? And we also have the force. And force, again, this is clear, but this is the force that may create, assuming there's torque, creates the rotation or the torque, okay? And again, this is also a vector. One last thing we have in the equation is theta. That is the angle between R and F. Okay, that's the angle between the moment arm vector and the force vector. Okay, so let's kind of check what we mean by these. I'm gonna give an example here. Let's just put it in here. So let's have a rod, and that is our object, and let's put our pivot point here. You don't need to show it like that. You can just sometimes show it like a dot, but I always write on it. That's my pivot point, just to represent it. And let's say that we have a force applied this way, and let's say that this angle is given as theta, okay? So how do I draw my moment arm? How do we define it? We start from the pivot point, go all the way to the force point. Force point is right here. Okay, so we start from pivot, go all the way to there, and put an arrow. That's your moment arm. Okay, so when I find the torque due to this, since it is R cross F, the magnitude is RF sine theta. Can I use this theta here? Is it the same thing? Okay, is it what I need to use in right here? Okay, so if you look at it, how do we define the angle? The angle is between R and F, okay? That may be a little confusing because it may look like that's the angle, but in order not to get tricked by this, do this first. Draw your vectors R and F starting from the same point, okay? And look at the angle between them now. Is that theta? It is not theta, right? It is 180 minus theta. So when you put it in here, I'm gonna get rid of this here. What we need to say here is then 180 minus theta, okay? Again, for sine function, it's gonna give you the same thing, but still, I suggest that you pay attention to this. And sometimes it's also 90 minus theta, and then sine function will change the value. So pay attention to those details and see where the angle is, okay? If you want to do the right-hand rule, let's use some other color. So what we do is we point our 4 fingers along the first vector, R. So try to point your 4 fingers along R. But right now we didn't fix our 4 fingers. Like it could really rotate 360 degrees, but just make sure your tip of the 4 fingers are pointing along R. And then look at which way the F is pointing, and then curl your fingers towards that direction. Okay. So in this case, your kind of thumb is going into the page, right? So that your palm faces down, kind of, not all like straight down, but it's like almost towards F direction, and you curl your fingers along F. So what I'm really doing is I'm going along R and now make a turn that direction, and that is a clockwise direction, or thumb is into the page, and that's why we say torque is negative or torque is clockwise. Okay, so in this case, thumb is into the page. We usually show that as cross and circled. Okay, and it comes from this cross product. R is your 4 fingers. Just gonna write that as well. Let's go here. And F is the one that you curl your 4 fingers towards it. Okay, so that's how you get the direction of the torque into the page. And be careful with this, because again we have some problems, and this is something that we need to figure out in terms of the direction. And this is how we do it. You use right hand rule to figure things out for the direction.